So I have for you here a short little video about special right triangles and how to use these two helpful triangles when you are doing trig. The first triangle that we want to talk about is called the 30, 60, 90 triangle, and it is named because of its angles. It has a 30-degree, a 60-degree, and you guessed it, a 90-degree angle. The sides are as shown. You do need to know where the sides fall. Know that the side opposite the 30-degree angle is 1. The side opposite the 60 is the square root of 3. And the hypotenuse, which is opposite the 90, is always 2. Now, we use this when we are finding the trig functions. So, for example, if we want to find the sine of 30, we can simply take the opposite over the hypotenuse, which would be 1/2. If we want to find the cosine of 30, we take the adjacent over the hypotenuse, which is square root of 3 over 2. And then when we want to find the tangent of 30, we take the opposite over the adjacent, which is 1 over square root of 3, which we would rationalize to be square root of 3 over 3. We can do the same thing for 60. So we can find the sine of 60, which is opposite over hypotenuse, or square root of 3 over 2. We can find the cosine of 60, which is the adjacent over the hypotenuse, or 1/2. And then we can find the tangent of 60, which is the opposite over the adjacent, or square root of 3 over 1, which is simply square root of 3. Now notice that these are opposite of each other. Sine of 30 is the same thing as cosine of 60. Sine of 60 is the same thing as cosine of 30, and the tangents of the two are inverses of each other. That will always be true for a 30, 60, 90. Now, if you know that you have a 30, 60, 90 triangle, you can figure out the sides as well based on these ratios that you have. And we'll talk about that a little bit more in a minute. The other special triangle is the 45, 45, 90, again named because of its angles. And you can see that because the two angles are congruent, so are the two legs or sides of the triangle. Now this one's kind of nice because you only have to find the sine of 45 once because the other angle is going to be the same. So the sine of 45 is 1 over the square root of 2, or when we rationalize that, the square root of 2 over 2. Cosine is going to be the adjacent over the hypotenuse, but it's going to be the same thing because the adjacent side and the opposite side are both legs and they are the same. And then tangent of 45 is simply opposite over adjacent, 1 over 1, which is 1. This is kind of nice because this helps us when we are figuring out sides that we don't know. It's also going to help us when we start talking about the unit circle. Now let's look at a triangle that does not have anything labeled, but we do know this is a 90-degree triangle, a right triangle. We also know that the two sides are congruent. So this has to be a 45, 45, 90 triangle. There's no other options, okay? So when you're finding the missing parts, don't forget that that includes the angles you need to find. And now we only have to really find one leg because when we do, we'll find the others. Now remember that our reference triangle is 1, 1, and square root of 2. We want to apply those ratios to this triangle over here. So for example, we should be able to know that, I'm going to call this side x, 1 over x should be equal to the square root of 2 over 8. And all we have to do then is cross multiply. 8 times 1 is 8, divided by square root of 2 is 8 over the square root of 2, or 8 square root of 2 over 2, which is 4 square root of 2. Which means that if this side is 4 square root of 2, then this other leg is 4 square root of 2 as well. And there's no math necessary to find that. You just know because they're congruent, they are the same length. So a 45, 45, 90-degree triangle, you can find one of the sides and you've automatically found the other, setting up a proportion using your special reference triangle. Let's try 30, 60, 90. And we're going to find the two missing sides here, okay? So again, let's look at our reference triangle. We know that the side opposite the 30 is 1, the hypotenuse is 2, and this other side is the square root of 3. Again, I can set up a proportion. So 2 over 5 is equal to x, 1 over x. And then we cross multiply. 1 times 5 is 5, divided by 2 is 2.5 or 5 halves. So this side over here is 5 halves. Then we're going to do the same thing with y. We're going to set up a proportion. So 2 over 5 this time is going to be equal to square root of 3 over y, and we're going to cross multiply. 5 square root of 3 divided by 2 is simply 5 square root of 3 over 2. And that's the length of this side. Do you kind of see a connection though? Do you see that this is 5, this is 5 halves, this is 5 square root of 3 over 2? You can kind of start to see the pattern maybe a little bit. That's going to become a lot more obvious when we start dealing with the unit circle and looking at some of the patterns there. Okay, we'll talk about that in a later video. For right now, I hope you can use the special right triangles, both the 30, 60, 90 and the 45, 45, 90 to find missing parts and to set up your trig functions.